we want to encourage user to drive the design process, and basically uh, instead of relying on CAD and design folks to give them a design input and put it by meshing and putting inside the model, we would like to encourage users to try the design enablers on a mesh level on their own, and then probably give the feedback back to the design folks, and so that CAE engineers will be upfront driving the design process. And this is kind of a first step towards that particular vision. The first set of design enablers that we have are the bulkheads and the doublers. As you can see, this is kind of again automotive example, but how the bulkheads and doublers are heavily used inside structural analysis, structural model. And the reason they're used is again they benefit multiple design attributes. NVH, safety, and durability are just few of them. And then they provide localized performance benefit. And another one is they can be integrated in towards the later phases of design cycle. So even if after the manufacturing tools are being kicked off, and if you see a certain performance deficit, you can put these design enablers at the later phases of design cycle and still get the performance benefit out of it. And again, they provide a very cost effective and mass efficient solution, because we are not basically adding upgauging the entire part, but we are just providing the stiffness or performance benefit where it needs. Okay, so this is an automotive model, and I will just use a view of underbody here. So as you can see, this is the bulkhead that the model already has, and the bulkhead workflow sits under 2D mesh and bulkhead. And this again, we have some options. What is the mesh size? What is the flange size? And how thick we want this bulkhead? But we can also use this. We can define the parameters in the micro button that I'm going to show you right now. So all I'm going to do with the space bar, I'm going to pick the entire sill or rocker. And here I'm going to pick a base point, which is going to be the longest face on the rocker, like this. And here I get a preview of the bulkhead. So I'm going to define the mesh size as 5, and then probably I'll increase my flange width. And as you can see, my preview gets updated instantaneously. I can even pick a material for the bulkhead, and I can switch the direction of the flange if I want. And if I'm okay with that, I'm just gonna press button to create the bulkhead. And this particular bulkhead workflow is pretty smart. It basically looks for the intersections and penetrations as well. So the model, the bulkhead that it generates, it's free of any penetrations, and it's a runnable model to begin with. So as you can see on your right is a bulkhead that's there in the design, and this is the bulkhead that I just created right now. Okay, as a next step, there's an there's a doubler. So the process remains similar for the doubler again. So I'm going to pick here these paths and elements, and I'm going to again pick base node like this, and it's going to give me a preview again. I'm going to say, okay, I want a mesh size of 5, flange width is 25, and then I'm going to have the length of the bulk doubler to be 250. Okay, and here I'm going to pick a material as well for this one. And additionally, with this doubler, we have also integrated connection control. So we can pick here, and we can go to the pre already defined connection control. So the doubler that we are going to generate will automatically be connected to. So I'm going to pick this connection control, and we are all set with this. And then I'm just going to hit this button to create the doubler. Again, doubler workflow is also going to go through this algorithm to make sure that there are no intersections and penetrations, and we get a good runnable model. So just probably in a few seconds before it generates the doubler. Okay, so we have the doubler created. I'll just hit all button. Yeah, as you can see, the doubler is generated uh, with the connectors. Okay, and as you can see, this particular doubler, it basically goes through. Uh, it looks at your parent surface, and if it has any holes or any access hole, it basically maintains those holes and access areas as well. So it's not like if you have an access hole on your parent part, you're going to lose that with the doubler. So this workflow basically takes care of the underneath mesh below it. So these are, let's say, few sections or lines that I got from design folks, or maybe I sketched it on my own. And I can go to this ruled surfaces here, and with Alt button, I can basically select the lines like this, and I can simply create the surfaces just like that. And even I can go and create this, and it creates the surfaces. And these surfaces, we can go to the mesh menu, and then we can basically um, create a mesh out of it.